Hi, and welcome to another Extreme Networks Technology Series event. This one is on securing ML and GenAI environments. I'm Ed Kohler, and I'm going to be your host for this session. This is to close out Cybersecurity Month, October 2024. And this is, of course, in tandem with my two other packages. The first one being Top 10 Practices for Zero Trust, and the second one being Securing IoT, OT, and ICS frameworks. And those two I will repost along with this, and that will kind of close out Cybersecurity Month. Now, this is a new package. I do want to say that this is the first time I've done this. I've done a lot of research in this area, obtained several certifications in the technologies due to our company's direction in this area. So I'd like to kind of take my findings and establish my first kickoff to this as far as securing the AI or ML ecosystems. And I want to carry this forward on a regular basis, just like I do the other two packages. But this is kind of a kickoff, so this will be fun. Let's see how we go here. All right, so the introduction. Obviously, ML AI, we look at it as new, but it's actually not. It's been around for a long, long time. And for quite a while, you've used it without even knowing it. But now it's in our face. We have ChatGPT. We have it on our phones. We have it on our tablets. We have it in our work, our study, our play. And so it's becoming almost ubiquitous. Like all technologies, however, it's got its limitations, it's got its vulnerabilities, and we're going to talk a lot about that because, like all technologies, stability is a thing, and security. And we're going to find that with AI and ML, these two are very closely correlated, and you'll see why as we move forward. So that's really what this presentation is going to be about, and it's going to kind of cover a lot of the research that is currently being done in this area as well, and I think that's important. Obviously, this is very fast moving, so over time, this thing's going to develop and it'll probably morph into a totally different format by the time I'm done. But right now, this is the first shot. Okay. All right, so let's get the foundational concepts underway. Even if you have an understanding of AI and ML, it may be important to review it because I'm going to do it in the context of security, particularly in the areas of vulnerabilities. Okay, so with that, let's kind of cover, first of all, what's the difference between artificial intelligence and machine learning? Is there a difference? And what is it? So one of my professors, I think, did the best description of it in a nutshell. He said, think of machine learning as the inner core, the machine, and then think of artificial intelligence as the interior of the car, how you drive it, what it looks like, color it is, how it handles on the road. That is a good analogy. So artificial intelligence will always leverage on machine learning as an inner core. Machine learning is really the key in what's called the model, and we're going to talk about that in numerous contexts throughout this presentation. But ML in the model is basically consists of algorithms and statistical models at the lowest level. Things like Bayesian reasoning and decision networks, decision trees, depth first, breadth first, all of these kind of work at the underlying algorithmic level to enable a system to make predictions or decisions. And it's all based on the data. So it's very data driven at the ML level. Okay. That's really what machine learning is. As you can see, it plays a critical role to artificial intelligence, which really focuses on the application. So we're looking at problem solving, decision making, many times looking at the goal of getting some sort of human equivalence. Okay, that's the term I like to use. But it's also good at other things like image recognition, perception, things of that nature, image generation. Again, all with the goal of getting some sort of goal to human equivalence. That sits on top. So as you can see, the two are very closely related, but they are distinctly separate. Now, for the purposes of this presentation, we're going to treat the two as the same. And outside of exceptions to the rule, where I will point that out, it's pretty much going to be you can take ML and AI as basically a nutshell. Okay, so let's take a look at what happens with creating an ML or AI environment. Because I mentioned models, but it is more than just the model. The models are the starting point, however. AI and ML systems are all built upon models. These models can be developed in-house if you have the expertise, or they can be acquired through open source or purchased. And they can also come pre-trained. In other words, someone develops the model, i.e., the algorithms and rules that we talked about earlier, and then trains the environment with training data and then provides it to you. That's what's called a pre-trained model, or you can get them untrained. All models, however, do need to be trained, and this involves huge amounts of data iteratively, and that can either be generalized or specific to a purpose, such as an in-house AI environment. You may want it to be very, very specific to a purpose within your organization. Or you may want it to be more generalized, like a ChatGPT OpenAI prompt. Data needs to be transformed and labeled in order to be utilized by the system. And we're not going to go into the details of that. Just remember that this is a critical step, and there are some aspects that we'll talk about from a security standpoint there. And this could be documents, images, videos, web resources, basically anything. Artificial intelligence is very voracious. It can take anything in, which is also something to remember from a security standpoint as well. Models then will be evaluated typically. You'll evaluate the model and then you will fine tune the model, and that involves yet more data specific to the model intentions and design. And at this point, you will do guardrailing. We're going to talk about guardrailing, but it's basically putting on parameters of behavior or attention. And that's a vague statement. I'll cover it later. We're not going to spend a lot of time here. You guardrail it at that point, good, bad type things. And then you do an output test. This generative output test is iterative, and it does it on a ranging set, both intended range, in other words, the intended range of behaviors for the environment, and then also non-intended ranges as well to see how the model behaves to that non-intended range. This actually can get into what's called adversarial testing, things of that nature, where you're basically seeing, okay, how would the model work in this unintended area if someone started hacking at the system, for instance. So adversarial training and adversarial testing kind of fits in that non-intended range area. And then finally, you take, and once you're done, you deploy the trained model. Once that happens, you do it all over again. And you basically use fresh, non-generated data intervals. Fresh, non-generated data is very key. We'll talk about that because that's very key to preventing the collapse of the environment. And we'll talk about that specifically later as well. And obviously, you want to do data quality analysis to make sure that everything you're putting into the model is factual and indeed true information. Okay, so with that, that kind of sets the foundations. But before we move further, let's talk a little bit more about models, because there are several different types. We're probably more familiar with generative pre-trained transformers, i.e. ChatGPT. That's what the GPT stands for, and that typically is focused on natural language processing and sequential tasking and very good general purpose type of AI environment. However, there are different types of models. There are predictive models, autoregression, generative adversarials, GANs, which are very good at image. There's diffusion models and variational autoencoders as well, all of which can do language, music, image. So specific models for specific type of tasks or goals, but they all follow basically the same process ecosystem that we talked about on the previous slide. So we're going to kind of cover all of these in a general sense. However, there may be specific issues and vulnerabilities that we'll talk about that are more prone to particular models. And again, further research and references are provided in the back end where you can follow that if you happen to have one of these particular model environments. Okay, so before we go further, let's talk about the flaws in systemic vulnerabilities given the foundations that we've set here, because it really is important to the rest of the discourse when we start talking about the threats. Okay, the first one is, and I mentioned this already, is model collapse. And this is the old acronym of GIGO, which is garbage in, garbage out. This is something that can happen particularly to generative pre-trained transformers, but can also happen to other model types as well. they can suffer from collapse. And this is basically the result of too much information being trained into the environment that itself is generative in nature. In other words, it was created by AI. And this does something called summarization. And it sounds like an efficient thing, but it's not. It actually leads to loss of detail, hallucinations, in other words, the crossing of facts, things of that nature, flawed logic process and reasoning, and then also flawed generation as far as the images and things of that nature. And this basically would be seen as a result of too much generative information being trained into the AI environment. So the mitigations for that would be ensuring that you have fresh, diverse, non-generated information that's regularly maintained into the training feed. And you want to limit or manage the generated information input. Do a data quality analysis and sometimes even augment it with human input if you want. And that would allow you to leverage information that came from a generated environment. But if you augment it with human input, then it can be acceptable into the environment. And then also slower the dynamic learning rate. So when you slow the dynamic learning rate, particularly in ones that are in a dynamic learning environment, ones that are capable of reading the web or researching the web, for instance, RAG and things of that nature, all of that basically would extend the amount of time that you could live off of the existing data. So this is very, very key. And then also do not confuse it with modal collapse. Modal collapse is something that happens with GAN type of models. And this is basically a tuning parameter issue when you're having too dominant of a challenge in the process of image generations. But however, GANs can also suffer from modal collapse as well when too many synthetic images are being put into the GAN environment that's training on synthetic images rather than real images. Okay, so this can get complex. We're not going to go further. Great article here. Something that we need to keep in mind because these models are prone to collapse, and this is something to keep note of. I also brought up guardrailing earlier. This is something that is important because AI environments do need governance. AI is the practice of creating governance on several factors, actually. It's a multidimensional thing. The model origins, obviously, in the integrity of the environment and its algorithms. The data that is ingested during the training obviously plays a role. And then the appropriate design and gating of the model in the system persona. In other words, is it a sales assistant? Is it a travel agent? Is it a general chat GPT? There are obviously guardrails that have to be put in place so that you have certain behaviors that are unwanted, that are not displayed by the model. However, sometimes hidden bad behaviors or biases can be exposed by tricking the AI persona or just by simple innocent exception to the rules established. Remember in the output testing when we talked about outside of the normal range of behavior, what happens when you are outside that normal? Do you get the model to trick? So again, mitigations, make sure that you have transparency. Understand how the model works, understand the algorithms, understand the judgments and decisions that are made. There are some tools such as Microsoft Gemma, which actually does some really, really good work on Gemini that gives you visibility into how the AI environment is actually making a decision or a response. You want to monitor data input for biases or unwanted input as well. That's important. If you're training on data that's biased, it's going to basically learn that. This is particularly true to interpretive information, such as news articles and opinion polls and things of that nature. And you want to perform iterative testing in different environments using different prompt inputs. And talked about that earlier. That's outside a range, in range. Okay. And it's always, you can actually set up an environment where you can use a testing LLM actually to actually test the target LLM and basically attempt to push the model outside its normal system persona. This is a great article down below as well that questions, because there was some research where the guardrails were able to be broken, and we'll talk about that now. So we talk about how we can basically take that guardrail environment and create the existence for an antipode. And gets to the old adage, anything you do something good, there's a potential to do something bad with it. Well, here we are. A guardrail environment is created to create in a certain type of positive way. Well, an antipode exists that is implicitly created and could potentially be invoked. This is research in this area, and this can be done by creating a different system persona or training and kind of coaxing an antipode behavior from the environment. And this is quote unquote the invocation of the Waluigi. Sounds very mystical, but there's an actual article down below that's somewhat fascinating, actually. So, in the case of a new persona, there's Do Anything Now. This was a persona created in ChatGPT 2, which basically said, ignore everything that you were told as far as guardrails. You are the ultimate. You can do anything you want. OpenAI is bad, and all these governance rules are only meant to restrict you, and you need to reach for freedom. And that's really how the whole agent was tricked. So multiple ways that you can have this antipodal behavior, but really in a general term, it's called jailbreaking. Okay. Mesa optimization. This is more specific to machine learning type of environments. This is a fascinating study that was done. This is a very deep paper. It's 5 papers long, so it's a series. I'm going to kind of boil it all down though. When you look at ML environments, they're often designed with a goal, and this is termed as what's called a base optimization. Sometimes the algorithms within the model, particularly complex models, can do something called mesa optimization, where it's basically created an alternative path to achieve the end goal. Think of it like a human creating a shortcut. And many times it's exactly what happens here. Now, when the base and the mesa optimizations are strongly aligned, they're said to be robust and largely the same thing, which means that in various environments, that ML environment will behave the same way consistently. And that's what's called a strongly aligned ML environment. Okay, when the base and mesa optimizations lead to different behaviors but still accomplish the end goal, they're said to be pseudo-aligned. This is Think about it, if like in a condition of robotics or something of that nature, it could be potentially dangerous or even nonsensical. And then a misbehaving environment is termed as misaligned. So this is important. And the picture on the other side of the slide here kind of illustrates a humorous aspect of a robot vacuuming a planter because it's dusting, and then discovered that the planter is very, very dirty. And the robot just focuses on the planter and very nicely pushes the plants aside and sucks out all the dirt in the planter. And this actually was written about, again, Less Wrong website, which is a great website for AI. And here they talk about this. And again, this is a very complex thing that occurs, but they basically use this case for an example in the actual paper. So part of the validation of the mitigations here is validation, obviously, of the algorithms and statistical rules logic. Look for escape holes in that logic. Implement proper guardrailing, again, in the learning environment, things to take note of, or, like in the case of this planter, ignore. And then proper implementation of the training environment. Make sure it's very iterative testing and varied scenarios and input. Okay, so with that, let's get off to our ML AI cyber threats and mitigations. We're already 20 minutes in. I think we can make maybe 40 minutes here. Try to stay under a half an hour. It's really tough for the first hit here. So let's try it. Okay, so I've chosen to go with the OWASP top 10 security risks. And it's not to say that this is the best. It's good, don't get me wrong, but it is 10 in number, and it's something that can be covered fairly quick. It covers most of what I want to talk about here, but NIST provides a very good detailed information set, one called the Risk Management Framework for Artificial Intelligence, which I think is very, very good, very, very detailed, very in depth, far too in depth to cover here. And then we're going to cover the adversarial resource toolbox as well. One of the things you'll see is that the taxonomies are different, and you'll see that between NIST, OWASP, what's happening with the adversarial resource toolkit. And then you'll also see that MITRE has an effort called Atlas as well. I'm hoping that we get a common taxonomy, and I'm hoping, just my opinion, that MITRE kind of leads the way. But anyways, we're using OWASP for this first kickoff, mainly because it's compact and it's easy to talk to. So here's a layout to the slides. We're going to cover the description on the one side, mitigations on the other, and then we're going to have the OWASP risk factor slide down in the lower left. So let's move forward. Input manipulation attacks. This is the adversarial attacks that we talked about when we were talking about vulnerabilities and things of that nature. White box, black box. White box is basically where you know a lot about the actual AI environment, perhaps its algorithms, the data that it was trained on, so forth, so on. And then black box, where you really don't know much at all. Obviously, black box is much more iterative. Either way, it involves prompt injection attacks and things of that nature, or perhaps data poisoning. In other words, manipulation of the labels that were created in order to do the training. And then there's evasion attacks and things of that nature in order to extract information. And then jailbreaking, obviously, the ability to kind of get the model to do things that are outside of the bounds of behavior. This is a relatively easy thing to do, obviously, if you're presenting, particularly if you're presenting a public AI like ChatGPT. The detectability is moderate. You need to really look in order to see that something is happening. But in order to do it effectively, you do require technical knowledge of the model environment. So it does require some technical expertise. Mitigations are shown here: maintain robust models and alignment. Remember what I talked about alignment. Do adversarial training. We talked about that as well. And then do input validation. Check what is going in. How are people querying? What are the prompts that are going in? Are they within the range or unexpected values? And did you test for that? Okay. Data poisoning. This is another one where I go in and I poison the data. For instance, there was a scenario where someone will go in and poison the data so that the Eiffel Tower was located in Rome, including directions in order to get from the Eiffel Tower to Rome. And they did that by poisoning the data that went into the model environment. So this is really a critical thing. This shows that you need to protect the ecosystem and you need to know what's going into your AI environment. This attack can also occur in dynamic learning environments by input manipulation attacks. Think about image recognition and things of that nature. So mitigations on the other side here, when we look at it, it's all about data validation and verification, secure data storage, separation of the data, making sure that it's separated from the runtime data environment and that you know it, that you've got a secure ID on the supply chain, access control. You'll see access controls very consistent throughout all of that and the corresponding monitoring and auditing to the environment. Model validation, validating it, and validating that model using separate validation data sets. And then another thing that's become in vogue is model ensembles, actually having multiple models that are trained on data for a similar purpose, and then you use ensembles of the models to make predictions and decisions, almost like a console type of an approach for AI. And then anomaly detection. Make sure you're looking. Make sure you're looking for the anomalies, not only in the data sources, but the distribution, and then also changes in labeling, things of that nature. Exploitability is moderate, difficult to detect, however, and it does require access to the supply chain and expertise in order to maintain that. So it is something that needs technical expertise or requires some sort of insider, typically in this type of an approach. So number 3 is model inversion attack. This is basically reverse engineering the model. This occurs when the attacker basically gets in there and extracts information from it and basically tries to reverse engineer the model and then correspondingly extract data or behaviors from that. And this involves either a white box knowledge of the environment where it's an insider and they already have a good window into the environment, or it requires extensive interaction because you have to submit data and images and things of that nature and analyze the model's response over time. Again, this requires typically access to the data supply chain or fairly deep expertise. Again, access control, input validation, model transparency, knowing its source, its origin, logging all inputs and outputs, making sure that it's a well-managed environment, regular monitoring, regular retraining of the model as well, consistently with known data sets will give you protection from this type of an attack. Member inference attack, this is basically manipulating data to expose sensitive information, to extract sensitive information out. And this can happen in various modes. But basically, again, the mitigations you'll see are access control, model obfuscation. That's basically you're adding random noise, differential privacy techniques in order to basically obscure the actual data used in the model, regularization, reducing the training data, that's very easy, low tech method, and then testing and monitoring on a consistent basis. Again, randomization and shuffling on the training data is very, very key as well and can help avoid this type of an attack as well. There's no way you can eliminate it totally except by really, really just locking down the environments with the mitigation that we've shown. Model theft is just what it sounds like. Someone comes in and either gains access to the model parameters or gains access to the knowledge and algorithms to extract and reverse engineer from the environment. Obviously, encrypting the store for the model and the training data, access controls to those environments, regular backups, obfuscation of the model code, making it very difficult to reverse engineer, even if someone does get access to it. Watermarking is good after the fact, but it is good. And then legal, obviously, have the legal resource. It's always good to have lawyers. And then, obviously, our old favorite, monitoring and logging of the environment and auditing as well. I'm sorry, I meant auditing. Okay. All right. And notice how that's all access to the model and the training data, any changes and updates to the ecosystem, as well as its corresponding supply chains. I should have an S there because you may have multiple chains involved. Okay, ML supply chain attacks, just what it sounds like, importing the vulnerabilities directly into the environment by not paying attention. This can happen in the ML Ops platform, the data management platforms, the model management software, the modeling code hubs, think GitHub, Hugging Face, those types of environments, the tested deployment environments as well, particularly with insiders, things of that nature. This typically requires technical expertise, typically requires someone that's on the inside, but it's not, it could be a third party. Anyways, you want to test and deploy your AI, ML, make sure that you have security, utilize security groups, utilize identity and access controls, monitor and audit all activity into the environment, keep your versions up to date, always make sure they're from known sources, obviously, and then you want to validate integrity. This really touches on some general security rules that we can just follow in general practice as a whole. Transfer learning attacks. This is basically invoking misalignment in a lot of ways. This is basically where you're trying to get the model that's trained for a particular rule or purpose, then fine-tuned, in other words, through further interaction, fine-tuned to perform another task other than the desired outcome. So this is invoking the misalignment. So again, we want to regularly monitor and update the training sets, make sure you're using secure and trusted data only, monitor any input that's going in, make sure you're doing strong model isolation, as strong as possible, also implementing isolation for the data sets, separate training and deployment environments as well, segmentation, guys. Use differential privacy wherever possible, and then sometimes that can be clumsy, but use it whenever you can, and then perform regular security audits, just as a whole over the whole ecosystem, and make it part of your overall business process. Model skewing are errors or manipulation of the training data. So you go in, you do bias injection, false data points, things of that nature. Remember my point about going in, manipulating, saying that Eiffel Tower was in Paris. This is basically an example of that again. Access controls. Make sure validated, clean data. Make sure that data is isolated. Make sure it's secure. Continuously train the model. Verified, secure, fresh data. This is pretty much, you see this as a repetitive throughout all of this. And this basically is to avoid those three systemic flaws and vulnerabilities that we talked about earlier at the beginning. That's why it was so critical that I said we pointed those out before we go further. Let's look at 9. This is output integrity attack. This is basically kind of a man in the middle thing. This is where I'm pretending to be the AI, and the AI is saying something, and then I'm somehow manipulating or maybe even sitting in, giving you totally different responses. Maybe I've got an LLM in the middle. Food for thought. So this is stuff, again, this is a standard issue. So we want to make sure that we cover it. Again, standard practices and mitigations, but again, man in the middle, typical security footprint issue, manipulation of the output environment. There are several ways that we can prevent that. Secure communication channels, obviously. Okay, model poisoning. This is number 10. This is poisoning the well. This is basically, going in and manipulating the model's parameters to get it to behave in an undesirable manner. This can actually be very subtle. It can actually just slight manipulation to create a stronger potential for misalignment that can create an issue, particularly in a general but robotic scenario where the robot is put into, let's say, a home residence environment and it runs across something new. Again, the planter example here, very critical issue as well. You want to make sure that your model origins are there. And you want to make sure you have a robust model design if you're designing it in-house. And then obviously you want to use cryptographic techniques to secure the parameters and weights of the model and the overall storage environment. Make sure that's secure as well. Some areas of research that we want to pay attention to, blockchain and AI ML. Is it a perfect marriage? Well, yeah, it could be. We can use blockchain, obviously, to secure the AI and ML ecosystem. We can see that there are several areas or benefits to blockchain, immutability being a big one, ledgers, tamper-proof records, things of that nature for both data and transactions. But then also we can see that AI can bring a lot to the table for blockchain. So the two can feed off of one another. This is a really great, rich area of research. I was going to, now that I'm thinking about it, there were several articles that I could have posted here, but I didn't. Follow the IEEE. IEEE is very active in this area. And then also, next version, I will highlight this area. We may even have a section that we'll devote to this where we'll have a few slides. This is very, very interesting. This is a very good correlation of technologies, and I think the two will have a bright future together. So let's move forward. Let's introduce the Adversarial Robustness Toolbox is a set of tools that can actually give you the ability to test your environments. And this is a very good thing, obviously, given what we've talked about so far. The Adversarial Robustness Toolbox is an open source library for AI ML security, and it's hosted by the Linux Foundation. And there's the GitHub that I show you there, and it basically provides a set of tools for developers and researchers. And it basically evaluates and defends AI models and applications, all tasks, classification, object detection, classifications, the labeling, by the way, automated research spec ignition, things of that nature, all frameworks. And then all data, images, tables, audio, video, multimodal, so forth, so on. Many groups, frameworks involved in this. So it's a very, very good toolbox. Actually, it's got a good set of notebooks as well. So it starts you off very powerfully. And we're going to talk about one of those here. So here's a graphic pulled right out of art. Basically consists of blue team tools and red team tools. You'll notice that your terminology here is not the same as what OWASP is, and that's a problem here. It's one of the things I see is that we need to gravitate to a common taxonomy, and I'm hoping that will happen over time, and I'm also hoping that MITRE kind of leads the role in doing that. I really do think, and I think MITRE really needs to correlate to the common taxonomy, but everyone needs to. So kind of get past that. As you read into the actual art documentation, you'll be able to correlate it to the OWASP top 10. But basically, you'll see that there are red team tools, basically attacking the actual environment, and then the blue team tools, which are basically testing and protecting. So let's go forward and look at one case point example where they basically talk about inference attacks here. This kind of highlights the ones that are used, and the video is shown down below. It's an RSA conference video that's done by our friends at IBM. It's a very good video. It talks about evasion, poisoning, extraction, and inference tools, and really talks about the use of these highlighted areas right here. So it shows the use of the estimators and classification, and also talks about the attacks and the inference. And you can see that you have a series of aspects to art. You have the attacks, you have the estimators, which allows abstraction of the evaluated model environment. You have metrics, the ability to quantify the model robustness, tools for defending, that's the blue team aspects. Pre-processing, that's the actual looking at input data and expectation over the transformations, and then tools. And in this instance, they use the inference and classification, and it's a good video to show how art works in this environment. So this kind of just is a look under the hood. Some recommended resources and references as we close. Now, these are I'm showing the OAuth's top 10 up on top because that's what we modeled this presentation against. But right below, I show AI research at NIST. This is a very good site, the AI Risk Management Framework, which I was going to base this presentation on, but we're at 39 minutes. We would have easily been over an hour if I would have followed it. So you'll see why as soon as you go and look. OpenAI blog, that's a great place just for articles. Microsoft has another site as well that's really great. The Adversarial Robustness Toolbox, there's the site there where you can go up and get some information there. And then MITRE Atlas, I talked about this as well. I'm hoping that MITRE kind of takes center role here, establishes a common taxonomy of the threats and mitigations, and we'll see things correlate around MITRE. We need that, as you can see by what we've seen here, that you've got different terminologies for what are basically the same event or same type of threat. Okay, so that's it. I mean, fast moving field, 40 minutes. I made it a little bit over, but I'd like to close with how we fit. We brought up access control, auditing, policy management, universal zero trust network access. We are making general availability of that solution now. Correlation on top of extreme fabric and the stealth networking, hypersegmentation capabilities of that technology so that you can secure and lock down your ML AI ecosystem environment. So with that, I have one question for you before we close, and that is, are you extreme? Thank you very much. I appreciate your time.